Today's lecture is about a different type of integral through a surface that has to do with calculating total flow. So when we have a vector field that represents something like flow of a fluid, and we have a surface sitting inside three-dimensional space, what we can do is we can try and measure the total rate of flow of that fluid through the surface. And this is calculated by a double integral, and this is sometimes called a flux integral. The main issue that we come up with here is that fluid flow is directional. So, for example, we could have a fluid that's flowing upwards through a surface or a fluid that's flowing downwards through a surface, passing from one side to the other. Those are measured in kind of two different things. Or if we have a fluid that's flowing parallel to the surface, then there's not actually anything switching from one side of the surface to the other. So when we're doing these calculations, we need to ignore flow that's parallel to the surface, just throw that out, and just remember the perpendicular component, but we also have to remember some directionality. We have to remember whether the flow is going up or down, basically. Even though inside three-dimensional space, it could be up, down, sideways. We have to have some way to measure the direction of what's going on. So when we calculate flow as a result, we need to know what we're measuring. We need to know a top and a bottom for the surface so that we know whether the flow is going from the bottom to the top or from the top to the bottom. And the way we usually do that when we have a surface, and especially a parametrized surface, is with a normal vector. At each point on our surface, there's a normal vector that points perpendicular to the surface. And so by looking at these normal vectors, we're going to calculate flux. And when we get a positive answer, that's going to mean that we have a net flow towards the normal vector. And when it's a negative, we're going to have a net flow in the opposite direction of the normal vector.